So this is day 1 of 2 for factoring. So you're going to factor today while I'm gone, and then you're going to factor again tomorrow. So I'm not going to go over the intervention worksheet because I think you guys can figure that out. But I will go over the 6 examples that I wrote out. So the first one is 2m squared plus 4m minus 30. If you look at your handout, my very first thing says all these numbers are even, which means we can factor out of 2. Factoring is a fancy way of saying every single thing can be divided by 2. But you can't just let those 2's disappear. Whatever you're dividing by, in this case, like I said, 2, has to be written on the outside. So 2m squared divided by 2 means that our 2's cancel out. And so we're just left with m squared. 4 divided by 2 gives us 2, but the m doesn't disappear. And then 30 divided by 2 is 15, but since it was negative, it obviously stays negative. Okay, so last year, depending on who you had, they probably showed you the X method or diamond method, however they call it. And basically, you multiply A times C to get B. And if you forgot what that is, anything that's to the second power, the coefficient on the squared term is A. The coefficient that's next to X, or a variable by itself, which is linear, is B. And then the number by itself is C. So what our goal is to find 2 numbers that multiply to give me A times C, but add or sum to give me B. So in this case, our A value is 1, and our C value is negative 15. So we're looking for 2 numbers that multiply negative 15, but add up to 2. And so, depending on who you had last year, your teacher may or may not have shown you to do a table, and I like the table method better just because it's a way to organize your information. So if you have a hard time guessing and checking in your head, if you put it in a table, you'll have a systematic way of knowing, did I already try that? And you won't be doing the same thing over and over. So the easiest one, most people start with 1. So since it's negative, that means one of my factors has to be negative. So if I have negative 1 and positive 15, well, that multiplies to negative 15, but negative 1 plus 15 gives me 14, which is not what I want. I don't want 14. I want 2. So then we could try a negative 3 and a positive 5. Well, negative 3 times 5 is negative 15. Negative 3 plus 5 is 2. So these, are the 2 factors that I want. So if we were filling out our little X or diamond, however you call it, it's negative 3, positive 5. Whatever numbers you find, you write them up as 2 separate things. So again, your 2 gets carried down because we took care of that guy in the very beginning. And then my first factor is going to be m. And since this is negative 3, it's minus 3. Times, this is a positive 5, it's m plus 5. And from there, we're done. So this particular worksheet just says factor. So that means there's nothing else to do. Later on, we might solve. But I really, really, really recommend that you practice this today and tomorrow. And if you kept your Math 2 notes, go look at them and remind yourself how to do them. Because we're moving on to factoring things to the 3rd and 4th power for this unit. So again, please, check your notes. If you need extra credit, do Khan Academy. It's due this Thursday, which is November 9th. Okay, so that's number 1. For number 2, this problem is 5k squared minus 20k plus 20. So again, when you look at your numbers, you can tell, well, all of these numbers are divisible by 5, meaning I can divide 5 out. That number has to be in front. So make sure that you carry him down. 5 and the 5 for the first term are going to cancel out. So they go bye-bye. And we're left with k squared. Negative 20 divided by 5 is negative 4. the k has to stay, plus 4. So now we're trying to factor the inside. That means make it look simpler. We don't want any square terms. It has to go. So you could do the x method on this one. I personally wouldn't, but I'm just going to show you that it would be multiply to 4 and then sum to a negative 4. And again, you're trying to find these two numbers. So if you're going to do this method, I recommend, highly, highly, highly recommend doing the table as well. It's a little extra work, but at least you won't be guessing and checking forever. So since the b value, which is this middle guy, is negative, but the last guy is positive, the only way that happens is if I'm multiplying by two negative numbers. That means this is negative, this is negative. So again, I always start with 1. Well, 1, negative 4. Well, negative 1 times negative 4 is positive 4. But when I do negative 1 plus negative 4, that's negative 5. So that's not what I want. Then we have negative 2 and negative 2. Well, negative 2 times negative 2 is positive 4. Negative 2 plus negative 2 is negative 4. So ding, 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 that's the guy I want. So when I put it in factored form, again, the 5 comes down every single time. And it's going to be k minus 2 times k minus 2. We don't write it like that. Because I have the same thing multiplied by itself twice, that's the same as k minus 2 squared. And again, bring down this 5. So the reason why I personally wouldn't have done this method is because I know it's a perfect square. So anytime you notice perfect squares, you're going to end up with something multiplied by itself twice. And so if you remember that, you can skip the step. If you don't remember that, obviously you can't skip. So number 3 is x squared minus 16. And if you notice, the first two examples had 3 things. That's called a trinomial. This example only has 2 things, which is called a binomial. So you can use the x method again. A is 1. C is a number by itself, which is negative 16. If something's not there, it's always 0. So I'm looking for 2 numbers, or 2 factors, I should say, that when I multiply them together, give me negative 16, but when I combine them together, give me 0. So if you notice on your paper, I didn't do this step, and that's because if you remember what I'm going to show you, then again, a step you could skip. So most people start with 1, so negative 1, positive 16, multiplies together to give me negative 16, but combines to a 15. So not helpful. Negative 2, positive 8, still multiplies to negative 16, but combines to a positive 6. Not helpful. I could do negative 4 and positive 4, and oh, that's helpful, gives me 0. So this is x minus 4 times x plus 4. And if you notice on your paper, I wrote difference of squares. So anytime you don't have a middle term, you're always going to end up with the same number, but one will be positive and one will be negative. That's going to happen every single time you have a square term minus just a constant, which is a number. So again, if we remember these patterns, you'll really shorten your workload by a lot. But again, you can always do it the long way. The long way doesn't hurt, it just takes more time. So just kidding, we're not on 5. We're on number 4, which is 2x squared plus 7x plus 5. So I can't divide out anything nicely because 7 and 5 are both odd and 2 is even. So you could divide, but you'd make fractions, and all of you hate fractions, so we're just not going to do that. So the top number is always a, which is the first number, the first coefficient. It's the one that's on the squared term, multiplied with whatever number is alone. So it has no x's, no k's, whatever variable we're using, it doesn't have a variable. So we're doing 2 times 5 to give me 10. So I'm looking for 2 numbers that multiply to give me 10, but add to give me 7. And in this case, we can already see the answer really is 2 and 5. But if you didn't see that it was 2 and 5, then you would do the factor chart that I've been doing. So there's some other tricks. I know your Math 2 teacher may have taught you a different trick, but I'm going to teach you factor by grouping. And the reason why I'm going to teach you factor by grouping is that next unit, or not, well, this unit after we finish this review, we might be, trying to factor things that look like this. And so that's 4, and that's called a polynomial. And the X method that your teacher taught you for quadratics won't work for something like this. But what I'm going to show you will work all the time. And I like things that work all the time, not just some of the time. So my first term, which is 2x squared, is going to remain the same. My middle term, which is 7x, I'm going to rewrite it using 2 and 5. So this is going to be plus 2x plus 5x. And my last guy, he stays the same, so plus 5. The reason why I can do this is, well, 2x plus 5x, still 7x. Once I'm done with that, I'm going to group in pairs. And then I'm going to do what's called factor by grouping, which means I'm going to look at this first pair and this second pair separately. So I'm going to look at 2x squared and 2x first and try to figure out what can I take out of 2x squared and 2x. Well, the easy one, well, they both have 2. I can take out a 2. They also both have an x. So x and x. And again, whatever you're dividing by, we consider that factoring. It doesn't go away. That person goes in the front. So 2 divided by 2, that's gone. X squared divided by x, if we remember our power rules, this is x to the first. Whenever it's division, you do 2 minus 1, which tells me I just have an x. If you forgot that, go back and look up your exponent rules or power rules. 2 divided by 2 is 1. X divided by x is also 1, so this is plus 1. So then you do the same thing, but with the second piece. So 5x and 5. The only thing I can divide out of both of those is a 5. So the 5 goes in front, and then I have parentheses. 5 divided by 5 is 1. I'm just left with an x. 5 divided by 5 is 1. So if you did this correctly, you should have the same thing inside the parentheses. And essentially we're factoring it out, which means we're going to write it once. So it's x plus 1. And then you put 2x and positive 5 together. And that's my answer. So whatever's written twice, you write it down one time. And then the leftover things, put them together. And if you need more help than what I'm doing, this is called factor by grouping. And hopefully you did this at least once or twice last year in Math 2. I know it's not the dominant thing, but it's going to be the most helpful thing when we extend factoring to third, fourth, and even bigger powers than that. Okay, so that's number 4. Number 5. So number 5 is 8n to the third, which is cubed, plus 28n squared. Uh-oh, this is definitely not something you can use that x on because it's to the third power. And it has 2 terms, which is called a binomial, which usually the x method we don't want to use for binomials. But we can do what we've been doing this whole time, which is factor. So 8n cubed and 28n squared. Well, 8 and 28 are both even, so if nothing else, you can divide out 2. But they're also both divisible by 4, so we're going to factor out a 4. And then n to the third and n squared, you factor out the smallest power. So I can take an n squared out of n cubed. So 4n squared goes in the front. And then we just figure out, well, 8 divided by 4, that's 2. N cubed divided by n squared is n. And that's because you do 3 minus 2. You can also do it the long way. N cubed is n times n times n. N squared is n times n cancel, cancel. I'm just left with 1. 28 divided by 4 is 7, and then the n squareds cancel each other out. So I'm just left with that, and I'm done. So if it doesn't suit the X method or diamond method, however you call it, then can you divide out anything? All right, so then the last guy is number 6, which is 12x squared minus 12x minus 45. So these numbers, they're not very pretty numbers. And so I would always see, can I divide first? And in this case, the answer is yes. And if my computer will let me write 5, we can get started. So 12 and 45 are all divisible by 3. So that 3 goes in front. So 12 divided by 3 is 4. And then 45 divided by 3 is 15. So now we're trying to do our X method on that piece. So again, the two numbers you multiply are first and last. So it's 4 and negative 15. So 4 times negative 15 to give me negative 60. And then add to a negative 4. So unlike the other case that I did with you, 4 and negative 15 aren't going to add up to give me negative 4. So I'm going to do my table of factors. So normally I start with 1, and I'll write it on there. So if I do a positive 1 and a negative 60, that gives me negative 59. And so you might be asking, how do I know that I should do negative 60 instead of negative 1? Okay, well, the reason I know that is that this middle term, I'm going to highlight over it in yellow, that's negative. So the only way you're going to combine a positive number and a negative number together and have your final answer be negative is if the bigger number is negative. So that's how I know. So 2 and negative 30, well, that gives me negative 28. 3 and negative 20, well, that gives me negative 17. If I do 6 and negative 10. So I know that there are some other terms in between, but again, if you start to realize a pattern, I wouldn't just do every single number just for doing its sake. Like, skip around, see if you can figure out a shorter way. And so 6 plus negative 10 is negative 4. So those are the two factors I'm looking for. So I'm going to rewrite that piece that I boxed in orange, and I'm just going to put a squiggly line because I don't really care about the 3 until the very end. So with that being said, I'm going to rewrite the middle term like I did last time. 4x squared. I'm going to do plus 6x minus 10x. Or actually, never mind. I did it the other way on your notes, so let me do it that same way. It won't change your answer, but I wanted to match what I did earlier. So I'm going to do minus 10x plus 6x minus 15. Okay, and the reason why it doesn't matter is you go back to, middle school, elementary school, whatever grade it is. 2 plus 3 is 5. 3 plus 2 is 5. So that's called the commutative property. So negative 10 plus 6, that's negative 4. 6 plus a negative 10 or 6 minus 10 is still negative 4. So the order is irrelevant. Okay, so, and sorry that my phone's going off in the background. I group them up and I decide what can I divide out of 4x squared and 10x? Well, they're both even, so a 2. Then x squared and x, I can divide out the smaller power of x, which in this case is x. And again, whatever you're dividing by, put that guy in front. So 4 divided by 2 is 2. X squared divided by x is x. Negative 10 divided by 2 is negative 5. And the x's cancel. Then 6x and 15, well, I can't divide out an x because the 15 doesn't have an x. But I can divide out 3. So I'm going to put plus 3. 6 divided by 3 is 2. So that's 2x. Negative 15 divided by 3 is negative 5. And again, yay, these are the same. If they're not the same, something went wrong. Whatever it is, you write it once because we're like factoring it out. It's like you're pulling it to the front. And if you want me to show you why that works later, I'd be more than happy to show you. Okay, and then whatever is left over, we put together. And so when you factor 4x squared minus 4x minus 15, you can break that into 2x minus 5 times 2x plus 3. But I drew this 3 down here at the bottom. I did a squiggly line so that I remember not to forget about it. So at the very bottom, my final answer is 3 times 2x minus 5 times 2x plus 3. And that's because the original problem was not 4x squared minus 4x minus 15. The original problem was 12x squared minus 12x minus 45. So you have to be sure to go back. Please, 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 to go back and make sure that you incorporate everything. So hope this helps.